I want to do a quick review of some of the major ideas of finding relative age and how to read a cross-section. So let's start with the first law that we learned, the law of original horizontality, which says that sedimentary rocks are always deposited horizontally. They're always laid down flat. If they're not flat, something happened to change them. Some things that might happen are tilting, folding, or faulting of sedimentary rocks. That occurs after. So here we have original horizontality, folding, exactly what it sounds like. The rocks get folded up. Tilting, the rocks are tilted. Faulting is normally caused when there's an earthquake of some kind. It causes the rocks to break and shift. This is a picture that shows a lot of different things happening in one diagram. This is actually not a possible scenario, but it's a picture of all the different things so you can see them. The oldest sedimentary rock layer is always on the bottom. Think about a stack of pancakes. The first pancake you put on the plate is the bottom pancake, and then the newest pancake is the one that's on the top of the pile. So the rocks get older as you go down. The rocks on top are youngest. Anything that cuts across a rock is younger than the rock. In this case, you can see a very clear fault along my cursor right here. Right? You can see that this side is higher than it was. The rocks broke and shifted up. On this side, they shifted down. So that had to happen after the rocks. They cut across the rocks, so the fault is younger than the rock. An unconformity is an erosional surface where rocks were worn away and new rocks were laid down on top. You can see there's two different patterns on either side of this green line. Down here we have tilted rocks. At the top we have flat rocks. It's called an unconformity because the erosion wears the rocks away and then the top rocks don't match up to the bottom ones. They don't conform. This white rock in the middle is called an intrusion. An intrusion is a rock that came up as magma to invade the space of another rock before it solidified. That means because they started out as magma that they are always igneous rocks. This picture shows two intrusions, a white one and a black one. You can tell by looking at it that the black one is younger. It cuts across the white one. So intrusions are always younger than what they intrude. So in this picture, you can see three intrusions. Take a moment to look. If you feel like pausing, feel free to pause. We have intrusion C, and then closer to the bottom, we have intrusion B and intrusion A. Which rock is the youngest? The one that cuts across all of them, rock C. Which rock is younger? Rock B or rock A? Again, because B cuts across A, B is younger. Oops, sorry. And then A would be the oldest of the intrusions, but there's a lot of other rocks in the diagram that you can put in order. So we'll do that in a minute. This question asks which is younger, the fault or the intrusion. So first of all, we want to know what the fault is. It's this red line where the rocks have shifted. The intrusion is over here and also over here. So hopefully you're getting a hint about which one is younger. In this case, the fault has shifted the rocks this way and this way on either side of the fault. Because the intrusion has been broken right here, you can see that it had to have been there before the fault. So which is younger? The fault is younger. The Regents would ask this question this way. What evidence from the diagram supports the inference that the fault is younger than the intrusion? So it's actually telling you the answer, but it wants you to provide evidence from the diagram that explains it. So it has to be something you can see in the diagram or in the cross section. In this case, you could say either the fault cuts across the intrusion or the intrusion is broken and shifted by the fault, something that compares the two things that you're talking about. When you have an intrusion, it causes contact metamorphism on the edges. That is because a magma intrusion heats up and metamorphoses all the rocks around it and near it. Its symbol is these little lines right here, and you can see the contact metamorphism all along the edges of this intrusion. That's because it was magma when it came in, it was extremely hot, and it burned the edges and changed these rocks, just these rocks right here on the edges, to metamorphic rock. That's why it's called contact metamorphism. So the Regents likes asking about that. What rock would you expect to find at the boundary of the igneous intrusion and one of the other rocks? So in this question, it's what rock would you expect to find at the boundary of rock B and the igneous intrusion? So the first step is you have to figure out what location they're asking about. So I'm going to highlight it. Right? That's the boundary of rock B and the igneous intrusion. Then you have to figure out what rock was originally there. To do that, you're going to open to page 7 of your reference tables, the top chart on sedimentary rocks. Feel free to pause right now if you haven't gotten your reference table out. So when you do that, you can see very clearly that B is sandstone. Now you need to know what rock sandstone will become when it goes through contact metamorphism. To find that, you're going to go to page 7, Metamorphic Rocks, and you're going to look at the 4 rocks on the bottom. All 4 of those can be created by contact metamorphism, and you're going to look under comments where it says metamorphism of, and in this case you're going to look for metamorphism of sandstone. You feel free to pause while you look. And you should see that the metamorphism of quartz sandstone is quartzite. So that's our answer. So what rock would you expect to find at the boundary of rock B and the igneous intrusion? The answer is quartzite. Another practice regions question. If you feel like you understand, feel free to stop the video. This cross-section represents a portion of the Earth's crust. Letters A through D are locations within the rock unit. At which location is marble most likely found? So to do this, you have to know that marble is caused by contact metamorphism, so it's likely to be in one, coming back. Marble is most likely found at one of the locations on the edge, so either A, B, or C. You want to look on page 7 of the reference tables and find out which rock turns into marble. And you'll see that it says under the bottom of page 7, it says metamorphism of limestone or dolostone. And then you want to look at the top of the page where it tells you what limestone or dolostone look like. And you can see that there's only one location that's next to limestone and dolostone. It's right here, B. At which location is quartzite most likely found? Same process, pause the video, try and figure out where quartzite is found. You should see that what changes into quartzite is sandstone. Sandstone is this polka dot symbol, so that means that the answer is location C. So you would find quartzite at location C, you would find marble at location C, marble at location B. Another question might be mark an X on the diagram where you would expect to find quartzite, so something where you have to actually draw the X. In this case, you have to find the sandstone and mark an X in any of the locations that I just highlighted in yellow where the intrusion crosses the sandstone. So just a couple sample regions practice questions. feel free to come see me during office hours if you have any additional questions on finding relative age in cross sections.